Hello everyone. Today let's solve the problem number 778. Swim in rising water. So what the question states here, we are given an n into n integer matrix grid. You can clearly see they have exactly shown the same thing here, right? So we are given an n into n integer matrix grid where each value grid of ij represents the elevation at that point ij. So each value represents the elevation at that point I comma j. So this is elevation 0, 2, 1, 3. So this is elevation, right? So at the point I comma j, rain starts falling at the time t. So rain will start falling at the time t. The depth of the water is also t, and the depth of the water is also considered as t. Rain starts falling at the time t, and at the end the depth of the water is also considered here t. This one we have to keep in mind. Rain starts falling at the time t and the depth of the water is also considered t. We start at 0, 0 and must reach n minus 1, n minus 1. Rightmost grid, this one, bottom right grid. We will start from this one, 0, 0. This will be 0, 1, 1, 0, 1, 1, right? We will start from this one, 0, 0, and we have to reach the bottom right grid. Nothing but in this case it is 1, 1. So what is the condition they have mentioned or rules they have mentioned here? We can move 4 directionally. They have given 4 directionally means either horizontally or vertically. Means either we can move left, this one right, either we can move left, either we can move down, or we can move up. So we can move 4 directionally. We can only move to a cell where the elevation is less than or equal to t. So here when t here, let's consider this one t equals 0. So we cannot move to the next this one grid here. So here t, here the elevation is 2. So the value has to be less than or equal to t. So here 0 less than or equal to 2. So sorry, I got confused here. So where elevation is less than or equal to t, right? 0. Suppose let's consider here initially 1, t equals 1, but elevation here is 0, right? So this has to be less than or equal to t. That's what they have mentioned here. So at the given time, what is our main goal then? Our main goal is to find the minimum t that is required to reach this one, minimum t or the minimum time that is required to reach the bottom right grid, or n minus 1, they have given. I hope this is clear. So in this case, by looking at it, this is a small grid, right? We can clearly see here at t equals 0, this one we cannot move to any grid because 0 less than this one, what do we call? The 1 is greater than 0 here in this case, right? We cannot move here. This one elevation 2 is greater than 0. So we cannot move. When t equals 1, then we can move this one. When time equals 1, then we can move here because elevation value is less than or equal to this one. 1 is less than or equal to 1, then we can move here. 1 is equal to 1, right? When t equals 1. So when t equals 2, then we can move to this one, right? When t equals 2, 2 is less than or equal to 2, yes, then we can move in the second step. So in the third minute, or the when t equals 3, we can move to third one as well, because 3 we will compare less than or equal to 3. Yes, 3 is equal to 3. So it takes 3 minutes. In this case, I'll just considering minutes just for the example sake. When t equals 3, or at the third minute, or when t equals 3, we can move to the this one, bottom right one, as they have asked in the question. So that's what they have given in the explanation as well. At time 0, we are at the grid location 0, 0. First one, this one, we cannot go anywhere else because 4 directionally adjacent neighbors have a higher elevation than t equals 0. Every this one value or the elevation inside the grid is having the higher value than 0, right? At t equals 0. So we cannot reach point 1, 1 until time is 3. So until time is 3, that's what we saw, right? We'll go step by step. When t equals 0, t equals 1, t equals 2, t equals 3. When time is 3, then only we can reach this one, 1 comma 1 or 3, bottom right, last this one, last cell, right? Last cell in the grid, bottom right one. So when the depth of the water is 3, we can swim anywhere inside the grid they have given. Similarly, you can consider for the example 2 as well. I hope the question is completely clear, and I hope I hope the question is completely clear. As usual, initially let's start with the approach followed by this one, edge cases one by one, and then finally write the code and discuss the complexities of the code that we have written. Initially, let's discuss the approach. So when I say approach, I'll just consider this one, example 1. So this is easier, right? So it is this I'll be considering. Let's discuss the approach first. So here we'll be making use of the Digistra's algorithm using minimum priority queue. We can just go with the min heap or min priority queue. So Leetcode provides built-in priority queue, right? So the code will be not lengthier. Let's go with the priority queue as priority queue. I mean minimum priority queue. So just keep in mind, we'll be making use of the Digistra's algorithm using minimum priority queue. So I have considered the same example, first example in the question that they have mentioned here, right? So example, this one I have considered, first example, same example I have considered. Let's see this one step by step. Initially, initial state here as this one we will consider 0, 0 initial state, right? We'll be considering 0, 0 when t equals 0 or time equals 0. We will start from 0, 0, and here elevation is also 0. We can clearly see this one, elevation is also 0 here. We start at 0, 0, elevation is also 0, water level will be 0, so we cannot move to adjacent cell because 0, 1, here you can clearly see 0, 1 has the elevation 2 and 1, 0, either we can move down, right, up or left. So in this case we can move right or down. So in 0, 1 and 1, 0, 0, 1 has an elevation of 2 and 1, 0 has elevation of 1. So both are greater than 0 initially. So initial state we cannot move anywhere. Right? This is fine. So in the step 2, let's come to step 2. So here what happens when time equals 1. So again, so now step 1 time equals 0, step 2 time equals 1. When time equals 1, then what we will do, water level is also here 1. Here this one, water level of this cell, water level. So I'll just do one thing. Me instead of showing this one, so let me do one thing here. So here, so water level here will be 1 as well. In this case, I'll just write it here itself. Water level is 1. We can move to 1, 0 here. You can clearly see when water level is 1, we can move to 1, 0 because here grid of 1, 0. Now grid of 1, 0 is 1. We know that this one 1, 0 we are considering, right? Grid of 1, 0 is 1 and time is also 1. When time equals 1 only we are considering. Water level is also 1, time equals 1 and grid of 1, 0 is 1. So we are checking grid of 1, 0 is less than or equal to t. In this case 1 is less than or equal to 1 or not. Yeah, 1 is equal to 1. So this will be true in this case. So we can move from this one 0, 0 to 1, 0 in this case, right? I hope the step 2 is completely clear. Let's come to step 3 here when t equals 2. So here we are considering when t equals 2, water level will be 2 as well. So now we can move from 1, 0 to 0, 1. Why we can move from 1, 0 to 0, 1? Because grid of 0, 1, we are comparing grid of 0, 1 with time, right? So here in this case, grid of 0, 1 has to be less than or equal to t. So 2 less than or equal to 2. Yes, 2 is equal to 2. This becomes true. Then we can move from here 1, 0 to 0, 1. So I hope this is clear. Next, when t equals 3, water level will be 3 as well in this case. So just give me a second here. Water level will be 3 as well in this case. So what we will do here, in this case, when t equals 3, so let me come here and this to this one. Water level is 3 here. We can now move from 0, 1 to 1, 1 here. So I'll just come here. We can move from 0, 1 to 1, this one, 1, 1, because we will check here grid of 1, 1 is less than or equal to t. So 3 less than or equal to 3. Yes, 3 is equal to 3 here. This will be true. So here we can move from 0, 1 to 1, 1, right? I hope this is clear at t equals 3. So we have to return the t now. We have to return the t at this point. T will be 3. So the output should be 3 in this case. We are returning 3 at this case. So the output that we got here is output. They have given 3, mentioned 3. So the output matches here. We also got 3. The output they have mentioned here is 3. So the approach works absolutely correct here. So minimum time that is required. So min time that is required here is, in this case, is 3, right? Minimum time required is 3. I hope this is completely clear. Let's discuss the edge cases one by one. So I hope the approach is completely clear. Now let's discuss the edge cases one by one quickly. So first edge case I'll be going with here is single cell. Single cell means we have only one cell, right? Input I'll just consider here 0. So output will be 0 as well. Why the output is 0 here? Because it is already at the destination. Time equals 0. So output will be 0 here. Let's go with the second edge case here. Second edge case here is straight path. So straight path. So this one, the example one that we considered for the approach, same thing. We can go with the first example that they've given in the question. So I'll just give you a 1, 2, 3. So the output will be 3, right? So we saw, I don't have to explain that one. We already saw that one in the approach, right? Third one is completely blocked path. So I'll just consider here completely blocked path. When I say completely blocked path, so here output will be, let me consider input 0, 100 and 1, 2 here, something. This is fine. So here output will be 100. When time, we must wait until t or time equals 100 to move through the larger elevation. So I can just visualize in the same way that I did for the example 1, that we considered example 1, or that we saw for the approach, that we saw in approach, right? So the output will be 100 in this case. So 0, 3 and 100. So the I hope all the edge cases are clear here. So the first edge case that we went with here is single cell, and the second edge case that we went with here is straight path, and the third edge case that we went with here is completely blocked path. I hope all the edge cases are clear here. So next, let's start writing the code. So initially what we will do, let's get the grid size initially. So I'll just give you n equals length of the grid, so that we don't have to write the length, we don't have to mention grid dot length every time, right? So that is the reason. Let's get the grid size initially. So second step is we are going with the minimum priority queue based on the time, because every time we need the small value first, starting from 0. In this case, in example 1, when t equals 0, next when t equals 1, then t equals 2, then t equals 3. Every time we need the smallest time, right? So that is the reason we'll be going with a minimum priority queue that is based on time. Let's quickly give here PQ new min priority queue of, let's set the priority here x of 0. This is fine. So we are just setting the priority. Every time we need the smallest, this one, right? Smallest time based on the time, as I've said here. So minimum priority queue based on the time. So next thing is we will be making use of the hash set to track the visited cells. So I can just write here. So we don't have to visit the cell again and again, right? Once we visit, we have to mark that one as visited. For that purpose, we'll be making use of the hash set. So this is fine. So the next step is we will start from the first cell, nothing but 0, 0 with its elevation as time. Initially t will be 0 and we are starting from this one, right? 0, 0 if you remember. So as we are making use of the priority queue, I'll just give here priority queue dot enqueue of grid of 0, 0. Fine. Somewhere I missed something. This is fine. Yeah. Grid of 0, 0 means first one, and the elevation and time should also be 0. Time is also 0. So we'll start from this one. I hope this is clear. We are starting from 0, 0 with its elevation as time here and this step. Next, let's write the simple while loop here quickly. The elements has to be present in the heap to carry on the further steps, right? So I'll just give here tq.size while loop. So yeah, this is fine. So size is function. I have considered this one. This is fine. Yeah. Next, while we have the elements in the heap, first what we will do within the while loop, we have to extract the minimum time position. How can we do that? Let time, comma, row, comma, column here. Let me give priority queue dot dq. We have to extract, right? So I'll just make use of the dq here. dq dot element. I hope this is clear. We are just extracting the minimum time position. After extracting the minimum time position, if we have reached n-1 or n-1 means if we have reached the last, this one, last cell, bottom right grid, then we have to return time, right? So this is simple if condition. If we have reached the bottom right grid, how can I write this one? Row equals n-1 and column also n-1. So I'll just make use of double ampersand here. Column, we have considered call, equals, call I have considered here, right? So yeah, column equals this one n-1. So I hope this is clear. Then what we have to do, we just have to return time. If we have reached the bottom right edge or the last cell, right? We have to return time in that case. So I hope this is clear. Next step is after visiting this one, each cell, we have to mark that cell as visited. So to mark that one, I'll just give here visited dot. I'll just make use of the add property of the hash set row into n plus column. This is fine. Next step, let's explore all the 4 directions. Nothing but we can either move horizontally or vertically. Horizontally means left or right. Vertically means up or down. So I'll just make use of for loop. Let's quickly write this one. drdc row column. So drdc of all the directions up, left, right, and down. So up, I'll just give you 1, 0. So this one has to be within array, I think. Array is somewhere. So this one has to be within the array, sorry. Just give me a second here. What did I miss here? Yeah. This is fine. 1, 0, 0, -1, 0, 1. And final step here is we can go with 1, 0. This one, up, left, right, and down we are considering. I hope this is clear. So the next step, let me give here, let's initialize new row. Row is dr, new column. I'll just give here equals column plus DC. We have considered DC here, dr and DC, this one. This is fine. So next step is we have to check if within grid and not visited. Check if within grid means it has to be present within the grid, and if it is if the elevation is not visited or not, right? So simple if condition, if new row greater than or equal to 0 and new column greater than or equal to 0 and new row less than n and new col less than n and not visited dot has just give me a second here. New row into n plus column we have to give here, right? So we are checking with we are making use of the has property here. This one, new row into n plus, we'll just copy paste the same thing here, new column. This is fine. So then what we will do, what we are doing here, we are checking whether if it is within the grid and if it is not visited, then we can just make use of the enqueue. Then we will push the maximum time that is required, right? So that is what we want. Maximum time that is required means least time until we reach the bottom right square, or we are pushing the maximum time that is required in this case. So I'll just give here PQ we have made use of. Let's make use of the NQ here. Let's go with the math.max of time my grid of new row and new column we have to consider. I paste this one, I have copied new column. This is fine. So here we have to consider new row and new column. So I hope this is clear. So we are checking if it is within the grid and not visited. After checking, we will just push the maximum time that is required, right? This is it. So let me format the code once and let me hit the run button. I hope this works. What we have here, new row is not defined. Oh, R has to be capital here. Line number 20. So where is this? Where is this? Where is this? Just give me a second. First one. So let me make the R capital here. Let me hit the run button. So you can clearly see here the sample test cases are getting passed. So let me hit the submit button. So now you can clearly see all the test cases are getting passed here. So the code works absolutely correct in this case. So let's quickly discuss the complexities of the code that we have written. So the approach that we went with here is Dijkstra's algorithm with minimum priority queue. So what would be the time complexity here? The time complexity would be here. Overall time complexity would be big O of n to the power of 2 or n square log n. Why it is n square log n here? Because each of the n square cells is processed exactly once. Each of the n square cells here is processed once with log of n square equals log n. Because insertion bar removal I am speaking of here. Log of n square will be log n because each of the n square cells is processed once with log of n square equals log n, insertion or removal in the minimum priority queue. So overall time complexity would be here big O of n square log n. So what would be the space complexity here? The overall space complexity would be big O of n square or big O of n to the power of 2. So here why it is n square? Because we are making use of the minimum priority queue and visited set here. You can clearly see here visited set. This one I'm speaking of. So we are making use of the priority queue and the visited set storing up to n to the power of 2 elements or n square elements. So overall space complexity would be here big of n to the power of 2. So the overall time complexity would be big of n square log n, and the overall space complexity would be big of n square. I hope whatever the solution that we have written is completely clear. For now, this is it. Thanks for watching, guys.